now that we've seen what to do with halves, let's consider what to do if we're going to try adding thirds. So thirds implies that I'm going to take this Post-it and I'm going to try to cut it into 3 equal pieces. So I'll estimate roughly what a third would look like. So a little bit of folding can be helpful if you're walking along with me at home here. And I'm going to think about what a third of a Post-it would need to look like. So I kind of bent it into 3 equal sections and I cut one of those equal sections off. If you want to cut the other 2 so that you have 1, 2, 3 thirds, there's your full Post-it again, you can definitely do that. And again, just for comparison, I'm using this blue one as kind of a baseline here. You can tell that comparatively, that is the equivalent size to 1 full Post-it. So I'm going to take this first Post-it that I'm visualizing here, and I'm going to call that 1/3. Again, I'm just going to stick it straight onto the block of blue Post-it so you can tell comparatively how big that 1/3 is compared to the whole. Now, it says to find the sum of these thirds. So what I need to do is find a third of a third, add that in, then a third of that, add that in, then a third of that, add that in, then a third of that, and add that in, and so forth. So I'm going to take this remaining piece. I have learned, because I am not good at this, that cutting thirds doesn't have to be lengthwise. Cutting thirds could be either way. So I'm going to do the best I can to make one more long skinny cut, even though I know that I am dangerously close to creating some sort of medical emergency for myself. But I'm going to cut this into thirds just so I can visualize it. So there's my next 1/3. So I took a third of a third. That would be 1/9. And then just for reference sake, I'm going to give myself the other remaining pieces so I can see them. Okay. So this is what a 1/9 looks like. And again, I stuck one down to my base just for reference, and I'll use this other one to cut up. So this is what a 1/9 looks like. Now I need to cut a third of that. And I know that I can't cut a piece that skinny anymore. That's just going to spell out disaster. So I'm going to fold it the other way. A third of something can be taken no matter what. So I'm going to fold it in thirds the wider way. Let's see if that helps. There's a third of a third. So a third of a third, let's stick that down, is going to be 1/27. Because a third of, or sorry, that was a third of a third of a third. So a third of a 1/9, which is 1/27. And now I'm going to take one of those remaining pieces and take a third of that. So cut. And that's fun, and also getting a little bit tiny again, to the point where I'm a little bit concerned that once again I might end up tempting fate here and put myself in impossible situations. But that little piece, which obviously is a little bit hard once it gets stuck, but you can probably tell. Also, this is not a Post-it commercial, but the Post-it glue on these things is fantastic. So Post-it people, if you're watching, send some free products. I am doing your best advertising here. A third of a 27th is 1/81. So we're down to a very small piece again. And at some point, again, when your sanity kicks in, you might start to ask yourself once more, okay, wait a minute, Herbert. Can I even bother with this? Like, am I at the point where I'm going to be cutting such impossibly small pieces? Like, watch my next cut. A third of this is, ooh, goodness gracious, so ridiculously small that now I'm here, like barely even covering anything. And then I'll take a third of that, which again is down to the point where it's so hard to visualize that I'm not even entirely sure that this is possible to do with the tools that I have. Like, now I'm here and gonna have to cut a smaller third. I mean, at some point these little bits are going to get so small, I'm not really going to do a thorough job of covering this blue space. In fact, it seems impossible that the answer to this question is going to work out the same as the first one I did with all the halves. Because remember with the halves, you could tell that by the time you got into the really skinny pieces, you had almost covered one full Post-it. Like by the time I got here, which hopefully you can kind of remember, I was really close to finishing filling in that little blue space. And besides the fact that I was getting a bit clumsy, it was definitely spatially filling itself in kind of nicely. But I'm already at the impossibly small stage of cutting, and I'm not even close to filling in the Post-it. So now here's the question. How much of the Post-it have I filled in? If I have theoretically glued down a third and a ninth and a 27th and 1 over 81 and 1 over 243 and 1 over a third of 243, which is starting to get into really big numbers, I believe that's 1 over 729, then really we should be asking ourselves, what does that look like? Visually, about how much of the Post-it does it seem I'm covering? So just again, to visualize the problem at hand, to visualize what we're talking about, I am talking about the problem 1/3 plus 1/9 plus 1/27 plus 1 over 81 plus 1 over 243 plus 1 over, and again, this is where I stopped cutting, 729, and now I'm into the impossible bits that I'll just call with an ellipsis, ... And then I'll ask myself, well, what appears to be the total there? What appears to be the sum of all of those thirds? It looks like, if I was to guess, I'm only covering about half of the available Post-it size. I'm only covering about half of what it used to be. So I'm going to guess for a second that it looks like about half is the sum of 1/3 plus 1/9 plus 1/27 plus 181 plus 1 over 243. Now, this is where you might be asking, well, Robert, this is a math class. Don't you have a calculator? Can't you be adding these numbers? Sure I could. 1/3 plus 1/9 plus 1 over 27 plus 1 over 81 plus 1 over 243 plus 1 over 729 certainly does look like my estimate's pretty good. 0.499314128.9. That's not bad. But technically I'm not done. Technically I stopped at 249. So shouldn't I keep adding? Shouldn't I be doing 1 over and then whatever 729 times 3 is? I should be. Ooh, 3 parentheses. There we go. Now, I do get a slightly different answer. But appreciably, it's not much different. And then if I do that answer times whatever this thing is times another 3, then I get another number. It's not the same number. I've clearly added a little bit, but I'm getting to the point where I'm adding such small values, it's not really making the beginnings of the decimal change. If I was supposed to round to, like, say the nearest thousandth, that's the first 3 decimal places, nothing's really changing that much in the first 3,000ths of a spot. And if I keep this process going, then I can do this for a while, but what do you start to notice about the values? Is it true that at some point we're not really making the decimal change much anymore? Because that, if so, goes back to the idea that we were talking about when we were doing the halves. At some point, are you not really adding anything appreciable of value? You're adding something so small that for all practical intents and purposes, we're saying, whatever, it's not even going to matter. Because if I told you to round your answer to 3 decimal places, you at some point would have stopped this decimal madness a while ago and said, it's 0.49999. That's just 0.5. That's close enough. That's 0.5. So now that we can see that it's not really necessary to add every single term in an infinite series, you're really just adding the first few and getting the gist of it, and then adding those little extra bits and giving up eventually, you're probably telling yourself, well, okay, then I don't really need to add 7, 8, 9, 10 crazy fractions. I can add a few fractions. But then that begs the question, well, how many fractions? Is 1 fraction enough? No, because that would have given me 1/3. That's 0.33. The answer was 0.499999. That wasn't enough. So what about 1/9? Was that enough? Well, 1/3 plus 1/9 is only 0.44, so that's not quite enough. I would have had to keep going. So then the question is, well, how far do you keep going? Do you add the first 3 terms? Do you add the first 4? Is it different per problem? Like, how would I know? So to answer some of these queries, I will tell you there is a formula. There is a formula for this that is going to allow you to basically plug into a formula instead of cutting paper, instead of making crazy fraction calculations in a calculator. So I'm going to challenge you for a second. In letter F, do you think you could derive a formula that would work? In other words, if the only formula we know is that of the geometric series on page 11, this formula you worked on in the previous lesson, do you think you could tweak this formula in order to make it work for infinite problems? Because the reason why I haven't used this formula up to this point, in case you're wondering why I'm just crazy, is because for that formula to work, we need n. We need a number of terms. These problems don't have a finite number of terms. They don't have an n. I'm not adding the first 4 terms. I'm adding the first infinite terms. I can't plug in infinity for n, can I? I want you to think about that. What would this problem look like? What would this formula look like if infinity was your n? And would that actually make sense in the context that we've been establishing? Would that give us answers that seem to kind of make sense? I'm going to have you skip this experiment with the fourths because, again, liability. One of us is probably going to cut ourselves, and who knows, we can't deal with that. We have too much to worry about in the world right now. We don't need to send ourselves to the hospital for bleeding due to math lessons. So let's skip the fourths, and instead, let's focus on this formula. I'm going to make the formula work. I'm going to pose that as a self-challenge, but in the next video, I will show you how the formula can work for an infinite problem. I just want to challenge you to try it on your own for a second. See if you can make it work, and then I'll formalize it to see if my thoughts aligned with yours.